We're going to be learning how to solve systems of equations, and one way you can do it is by substitution. Now, if you watch any kind of sports, you see substitution all the time. Football, they have substitutes. Basketball, they have substitutes. In basketball, you got 5 guys on the court, and somebody's got to come out sometime because they have to get water, they've got to rest. It's a lot of running. So, if they substitute someone in basketball, that means they replace a player with another player. Now, that player does the exact same job as the one before it, they just look a little different. So that's what we're going to do in math right here. Now, you've been substituting for a while. This problem right here is not very difficult. Solve for x when y equals 2. And you have that y equals 5x plus 12. Well, they gave you some information. They gave you that y equals 2. So that means 2 is the same thing as y. Now, those two things look different, but they're the same. Now we have y here. We can take this 2 and substitute it for this y in order to find x. So let's take care of that. Let's do it. So what we're going to do, we're going to put in 2 for y. 5x plus 12. Subtract 12 from both sides. Okay, so we get 5x equals negative 10. Well, now to find x, the next thing we need to do is divide by 5. So if we divide by 5, x equals negative 2. So we have an x, we have a y. We can actually write these as an ordered pair. X was negative 2 and y was 2. Our x's come first and our y's come second in an ordered pair. We know that. And this is where these two lines would cross on a graph. It's their intersection point, like in an intersection in a road or a four-way stop. This is where they would intersect. Let's look at the next one. Solve using substitution. Okay, we're still substituting. It's the same thing. It just looks a little more complicated, but we still have x's and y's. You have 5x plus 2y equals negative 16, and y equals negative 2x minus 6. Where do we start? Let's see. Well, this one is solved for y, and this one has a y. This y is equal to a lot more than a number this time. It's equal to negative 2x minus 6. Well, the good news is we're going to treat this pretty much the same as we did in the last one. We are going to substitute once again. We're going to take all of these items right here, negative 2x minus 6, and we're going to put them in for this y in this equation. Okay, so we have 5x plus 2. Now we're going to need some parentheses because this is a lot of stuff that this y is equal to. So negative 2x minus 6 equals a negative 16. Now if you get to this point and you still have two variables, you've done something wrong. You're going to need to go back and check it and fix it, okay? Don't keep working. You won't be able to solve this problem. So now, distribute, okay? We think back through our steps we learned at the beginning of the year. So we've got to distribute. 5x is going to equal, or 5x plus, well, 2 times a negative 2x. Let's see, that'd be a negative 4. Wouldn't we need a plus sign? We need a minus sign. So this would be a negative 4x. And then 2 times a negative 6 would give me negative 12 equals negative 16. So now, our next step would be to combine like terms. Do we have any terms that look alike? Yes, we do. 5x and negative 4x, that would give us a positive 1x. Then we can't combine 12 with anything, and we have negative 16. Well, now, we just got to solve for x. Now, if you wanted to put a 1 in front of that x, you could. But it's not necessary. Remember, we've talked about this. So we get to here, and we get that x equals negative 4. Wonderful. We found x. But guess what? We still have to find y. So next is find y. That's important. Okay? Can't have a system without two answers. So, here we go. We got to find y. And we knew that x was, what was x? X was negative 4. So we know that x equals negative 4. What are we going to do? Well, we can take and we can substitute into either of these equations. Now, one is more simpler than the other, but we can do either one, and I'll do both. But first, I'm going to do the easy one. The easy one would be y equals negative 2x minus 6. So if we take and we substitute in for x, because that's what we know over here, negative 2 times negative 4 minus 6. Well, we know that negative 2 times negative 4 would be a positive 8 minus 6. So y equals negative, oh, not negative, but positive 2. Okay, so y equals 2, x equals negative 4. We can write this as an ordered pair, negative 4, 2. Let's just double check. Let's check the other equation just to see. Let's see if we did it right. So we knew that x equals negative 4, right? We're going to do equation 1 this time. So 5x plus 2y equals negative 16. And we're going to substitute in for x, and we're going to put in negative 4. So 5 times negative 4 plus 2y equals negative 16. So 5 times negative 4 gives us a negative 20 plus 2y equals negative 16. And then we're going to add the 20. That's going to make it positive. So you got 2y equals 4. Then all that's left to do is to divide by 2 so that y equals 2. So we get negative 4. 2 is our ordered pair. Well, is that what we got on the previous slide? It is. Negative 4, 2, negative 4, 2. Either way works. So the solution to this system of equations is negative 4, 2. This is how we write it. Okay? We write it as an ordered pair. We don't write x equals a number or y equals a number. We finish it, we clean it up, we make it look pretty, and we write it as an ordered pair. Because what this means is this is the intersection point. Eventually we're going to graph these things. And when we solve systems by graphing, this will be our answer. It will be an ordered pair. Okay? So it's all going to connect together. Just bear with us for a little while. Okay? And so this is how we solve systems using substitution.